Okay, what kind of questions did we see on page 53, 54 you want me to go over? Yeah. Number 9. 9? All right. Number 9. We got 4x plus 6y minus 11 equals 2x plus 4y minus 9. And they wanted us to get y all by itself. Correct? So that circled y just indicating what we want to get by itself. All right, so we're going to have to move things back and forth across the equal sign. So we could probably do a couple things at once. I'm going to subtract 4y from both sides. So that's going to cancel. That's good. But then I can also say, let's get 4x and move that over. So those are going to cancel. And then let's add the 11. And those cancel. So it looks like everything should cancel and move. We might have a little bit more to do at the end, but let's see. So the 4x's are gone. They moved. That one moved over. Negative, or 6y minus 4y is 2y. The 11s we moved over, so it's no longer on the left side. Let's see. 2x minus 4x is negative 2x. The 4y's canceled out. Negative 9 plus 11 is 2. You feel okay with the work I've done so far? Yeah. Okay, so now I just want to get y all by itself. So divided by 2. Those cancel. Negative over negative over positive is negative. So I get negative x plus 1. Done. Is that okay? What else did you see? Yeah. 7? Sure. Can I move off this screen? Good. Okay. So we want to get y by itself. I truly think this is the right answer to go with. Those cancel, so I get y equals 1/3 x minus 27 plus 3. I'm totally 100% content with that as an answer. Okay? But I know some of you are like, well, I'm going to do this. X third of 27 is 9 plus 3. So some people might want to take it all the way down to here, where that meant you did extra steps. So this and this or that, your choice where you want to go. I personally would choose the top one. Not worry about doing the rest of the work. Okay, but if you take it down to the bottom, you're okay. That's a 1/3. What other questions might you have for me? What other questions out there would you have for me? Yeah. Yeah. And again, we want to get y all by itself, okay? So we could probably combine a lot of things together. Did I do this one already? Looks so simple. Oh, just like, okay, cool. So I'm going to subtract the 2y. And I can do more to it if I wanted to. Let's see, I can go minus 2x. I could go minus 5. And let's clean it up. Okay, so those cancel. That gives me 2y. Those cancel. That gives me 3x minus 2x is x. Those cancel. That gives me plus 6. Does that seem okay so far? So So now I want to get the y by itself, and y is being multiplied by 2. So if I divide everything by 2, cancel that, so I can y equals x over 2 plus 3. Or some people might choose to do this. And I think both answers are 100% appropriate. Okay. Anything else? Good? Happy? Content? All right. So what we're going to do today is, I don't know how many more rewriting literal equations I need or you need. So what we're going to do is we are going to go to the review. And what we'll do is we'll do a couple at a time, give you some time to try it, and then move on. So I'm on pages 57. So go ahead and try 1 through 4. Try 1 through 4, and then we'll take, I'll give you a couple minutes to try it on your own, and then we'll go back to, I'll work them out for you, okay? So, all right, so very first problem, I have some fractions in there. I have denominators of 2 and 4. So I think if I multiply all 3 terms by 4, I'm going to be able to cancel out my fractions. What do you think? Okay, so I'm going to multiply this by 4 over 1, this by 4 over 1. And when we multiply fractions, 4 times x is just 4x, plus this cancels that twice. 2 times 1 is 2, equals 4's cancel out, so that gives me 1. 3 times 1 is 3. Does that make sense for you? Okay, and again, that clearing of fractions is a huge skill, and we will work on it almost all year, okay, when it's appropriate. All right, so now I can start doing both sides. So I think subtract 2, those cancel. So I have 4x left on the left side. 3 minus 2 is 1. Divide each side by 4. So I get an answer of x equals 1/4. Answer's done. I would say on the test that you'll see next week, you will definitely see that kind of problem. Okay? My plan is for Tuesday, okay? So we're going to review quite a bit. So make sure if there's something that, even if we have to go back to a problem or do a similar problem, let me know. We're happy to do it. All right, friends, for problem number 2, what do you think we should do?
Multiply by 4.
Yeah, it's z over 4. So if I multiply this by 4 over 1 and this by 4, those cancel, leaves me as z equals 48. There's our answer. It's all done. Okay, so the first one's kind of multiple steps. The second one's just a one-step situation. Is that okay?
Mm-hmm.
Can I move on? Cool. Let's move this up a little bit. All right. For the next problem, what do you think I should do to get n all by itself, my friends? Divide by 5, and I'm dividing by 5 because 5 and n are being held together by multiplication. Agree? So I'm going to divide this by 5, and I'll divide this by 5. Cancel, reduce my fraction. Negative 20 over 5 will reduce to negative 4, I believe. A lot of students on that kind of situation, you drop the negative sign, and unfortunately would miss one of the 2 points if you just left me an answer of n equals 4. So watch the signs, okay? Number 4, what do you think? Subtract 5, absolutely. So I'm going to get g equals 17 subtract 5, 12. Okay, pretty straightforward. Will you please try problems 5 through 8? Try 5 through 8, and I'll write them up here as well. All right, first problem. Let's see. If I combine that and that, it's going to give me 23 plus 3p equals 23 plus 3p. What can you tell me about this problem as it sits right now? Yeah. It's going to be infinite. I have the same exact same thing on both sides. Now, we could work further saying, oh, okay, I'm going to subtract 3p, I'm going to subtract 3p. Those cancel each side, so I get 23 equals 23. That's supposed to be 23. Sorry. So this is definitely an infinite solution because that's 100% true. But you don't necessarily have to take it down that far. If you can realize at the step above that 23 plus 3p is the exact same thing as 23 plus 3p, you know you're dealing with an infinite solution. Okay, let's see, number 6. What should I do to both sides? Subtract. It's positive 7, right? So yeah, subtract 7. That cancels, so I get 4y is equal to 32? Okay. What should I do last?
Divide by 4.
Divide each side by 4. Those cancel, so y is equal to 8, I believe. And obviously your calculator did that real nicely. Go 32 divided by 4, enter 8, yay. Any questions on those two? Seem good in the hood? Can I move down to the bottom? All right. And a couple of you had questions on number 7 because you're like, oh, what should we do with this decimal? Well, let's not panic about the decimal yet because the nice thing is I have a positive t and a negative t on the same exact sign as equal sign. Then I wind up seeing that 3 is equal to 11.5. And 3 is definitely not equal to that. So that's going to be no solution. Or you can put the circle with the slash through it, something like that. That would work. Problem number 8. It appears that 4x and 6x, those are like terms. They're on the left side of the equal sign, so I can add those together. 8 subtract 5 is positive 3 is equal to 30. Does that seem okay? Then it looks like I should be able to subtract 3 from each side. Those cancel, so that gives me 10x on the left, 30 on the right. What's my last step, my friends? Divide by 10. That cancels that, so x is equal to 30 over 10, I think is 3. Cool. Any questions on those first 8 problems? Let me ask you this, my friend. Yeah?
Oh, I was just saying, like, on the first one,
Where we cleared the fractions?
yeah, like, I get the canceling out. I just, like, with the second one with the 2 4s canceling, that one's easy, but, like, with the 4 and the 2, how do you get 2? You just subtract them, or?
Ooh. Do you want me to do one similar to number 1?
Sure.
Okay. Let me move this out of the way. So we'll put a little note, and then you can put this note on your page if you need to. So this is similar to the first one, okay? So let's just, I'm going to make one up. Now, if I make one up, it might be not the prettiest answer, but the thought process should be the same. So let's say we have x over 4 plus 2 over 3 equals 1. Is that okay? So I have 2 denominators. You agree with me?
Yeah.
And they happen to both be different denominators, right?
Yeah.
So we have to think, okay, what number would 4 and 3 both go into that would give me a whole number? 12. Yeah, totally go 12. So 12, because of this and this, 12 is the number I want to use, but I'm also going to realize that I'm going to multiply by 12 over 1 as well, because 12 over 1 is the same thing as 12, right?
Yeah.
So if I have a fraction, I'm going to have it as 12 over 1. But if I have a whole number or a number with a letter, I'm going to have it as just 12. So I'm going to multiply this by 12 over 1, this by 12 over 1, and this by 12. Do you agree so far with the math that I'm doing? Okay. So when I multiply fractions, I can go top to top, bottom to bottom, and reduce. Or I can reduce first and then multiply top to top, bottom to bottom. And there's not a right or wrong way to do it. It's just however you feel appropriate. So on this one, let's multiply top to top, bottom to bottom. Do you feel that is the same as that?
Yeah.
And then 4 goes into 12 3 times. So this comes down to 3x plus, and then same thing, top to top. 12 times 2 is 24. 1 times 3 is 3. If I go 24 divided by 3 on my calculator, I'm going to get 8. Okay? And then this last one is just 1 times 12, which is 12. And then that becomes a very simple problem, two-step problem to do without fractions anymore.
Oh,
Okay? So I showed this. So other ways I have done this problem, I might have done it where I would have done, let's see. I might have said, oh, that goes into its once, that goes into 3 times x is 3x. That goes into 12 4 times, multiply those together, 8, and I still get the 12. So this then becomes the same thing as this. Okay, and then this one would just simply,
yeah.
that's the easier part right there, I believe. Yeah, look at that, I came up with a fraction for an answer, but that's okay. 4 over 3 is a reduced fraction. So that's similar to the same thought process that number 1 would have.
That helps.
Cool. And I'm just curious, not because your mind's thinking wrong, do you see the way where we multiply top to bottom, bottom, then reduce? Or do you see it as reduce, then multiply top to top, bottom, bottom?
Like which one I see better?
Yeah.
Top to top.
Okay, yeah, go with that then, please. Yeah. No, that's great thought process. I love it. All right, friends, would you try 9 to 12, please? 9 to 12. Okay, problem number 9. I'm going to distribute 5 over the parentheses there. That's going to give me 10c plus 35, and then minus 3c. Agree?
Yeah.
Equals, distribute 7 over that parentheses, so 7c plus 35. Does that seem okay so far? Okay. Then, because I have both of those on the same side of the equal sign, I'm going to go 10c minus 3c, which is going to give me 7c. My friends, is one side the exact same as the other? So what is that guaranteed to mean? Infinite solutions. Okay? Now, if you chose to, you could go, I'm going to subtract 7c from both sides, and then I get 35 equals 35. And that has the same ramifications, but just be aware. Yeah?
I kind of did it a little different, but I got the same thing.
Sweet.
I did I minus 35 from both sides.
Oh, okay. Yeah, yeah.
And then I got 10c plus 3c equals 7c, and then I minus the 3 over the 10 and got 7c equals 7c.
Oh, that totally works. Yeah, that's perfect. Good, good. I like your shirt, by the way.
Thanks.
Yeah, baby. All right, number 10. Number 10, we happen to have 2 fractions. Both of the fractions happen to have the exact same denominator. Agree? Okay, so they both have, let's see how my highlighter works. I have this denominator and this denominator. Okay, I'm actually going to dim my lights because it's not showing up as well on my video. Hopefully the video catches that a little bit better. Yep, it did. All right, so friends, I need to multiply everything up there by either 2 over 1 if it's a fraction or 2 if it's not a fraction. Does that make sense? So I'm going to multiply this by 2 over 1, this by 2, this by 2 over 1, this by 2, and this by 2. So if I do that, that's going to give me 6 over 2b, which reduces to 3b. 2 times 6 is 12. Nothing happens there, so I'll just bring that down. This one becomes 2 over 2b. 2 over 2 is the same thing as 1, or just b, equals 2 times 15 is 30. 2 times 2b is, oops, 4b. Is that okay so far?
Yeah.
And it looks like I have b's on the same side, so 3b plus 1b is 4b plus 12 equals 30 plus 4b. I have a 4b on the left side. I have a 4b on the right side. If I subtract 4b to start, I'm going to wind up getting 12 is equal to 30. Is 12 equal to 30?
No.
No. So this is a no solution. There might have been other ways you might have solved this, and you got one thing equals something completely different, and then one of the things is not a letter. They're both numbers. So that's the same idea. Questions on either of those two? Okay, let's move this up. Okay. This is ready to start moving things back and forth over the equal sign. Agree?
Yeah.
So, I might choose to, I don't know, I have to start someplace. I'm going to subtract 3 from both sides. So that gives me 7n equals 2n plus 20. Okay, now some of you might have chose to move the n first, and it's still going to work out the exact same thing. Then I'm going to subtract 2n from both sides. Those cancel, so I get 5n is equal to 20. How do I get n all by itself? Divide by 5. Good. So n is equal to 4. What did I do?
It reminds me of problem 3, because problem 3 is n equals -4.
Oh, wow. I guess that was coincidental that I think a lot of times when we're working these problems out, we're trying to get them to, we don't want like some 758,213 for an answer. That gets a little crazy. And that's not really showing that you understand the algebraic concept. That's just showing you have number sense. Hey, number 12. I do have one fraction. Agree?
Yeah.
So let's do this. I have two sides to this problem. If I were to multiply this by 2 over 1 and this by 2, those cancel, so that leaves me this basically. If I distribute a 1 over the parentheses there, I wind up with 6x plus 4. Is that okay so far? Yeah.
Is it really necessary to do that though? Because it's only 1/2.
Oh, yeah, you totally could have done 1/2. So you're getting a 3x plus 2? Oh, yeah, that would work too. Yeah, I like that. See that? I'm going to distribute both sides over the 5. So I'm going to get 10x minus 40. That's now pretty simplistic to go and solve. All right, where should we start? Who wants to start it?
-4.
Subtract 4 from both sides? I'll go with that. You might have chosen something different, but that's okay. Agree so far? Then I want to subtract 10x from both sides. So that's going to give me negative 4x equals negative 44. What should I divide both sides by?
-4.
Negative 4. And a negative divided by a negative is?
Positive.
Yeah, so those cancel, so I wind up getting x equals 11. And it's positive 11 because it was negative 44 divided by negative 4. Yeah.
Did you minus the 10x so it become a minus? So or it'd be
Oh, I was just trying to get x on one side and
Okay.
everything else. I mean, I could have started this problem by subtracting 6x from both sides. I could have subtracted 10x from both sides, or I could have added 40 to both sides. I could have started at any of those spots, and it's still going to come out the same. Okay? So, friends, do me a favor. This evening, those 12 problems that we just worked out, you worked them out, and then I went over them. Take a really good, honest look at them. If there's any of them that you want me to go over a little bit more or different versions of it tomorrow, we'll do that. I'm not assigning homework for tonight other than to take a look at page 57, 1 through 12. We already did it in class, so theoretically it's all done. But if you take an honest look at it for me, and be honest, if you're not sure why it worked out a certain way, come to class tomorrow, we'll figure it out, okay? We good? All right.